Hi, my name is Erik Sonboer, based in the Netherlands. My role is in EMEA 1 for Dell Technologies, where I am a cloud and automation specialist. Today's subject is persistent storage into Kubernetes through our CSI drivers, and specifically a focus on doing snapshots within this environment. So let's first go out and explore our demo environment. First of all, I have a Unity standing by, so I'm just logging into the Unity array, and this Unity array is completely empty. So it is unconnected to anything. It doesn't have any volumes provisioned. It doesn't have any host connectivity yet. So it's just a clean Unity just sitting there. It is a virtual appliance, which means it's slightly smaller and it can be a bit slower than a physical one at times. So please bear with me during this demo. Because we're talking about a virtual edition here. So as you can see, it is completely empty. There's no volumes defined as of yet, so it's no LUNs. There's no host access, so there's 0 hosts added at the moment, so it's completely empty and, for that matter, ready to go. The other piece of our little environment is a tiny Kubernetes cluster. So if I do a get nodes on this Kubernetes cluster, you see that it's a tiny one, right? It's got a single master and it's got 2 worker nodes. So all ready to go. I've already installed several CSI drivers in this environment, and you can actually see that when I do a kubectl get storage classes. You can see that there's PowerMax connectivity for Fiber Channel and iSCSI. There's a PowerStore iSCSI and a PowerStore NFS connectivity, and we are also running Unity, so that's our demo for today, connectivity through iSCSI or NFS. For today's demo, we'll be using iSCSI. The pods that we have in the namespace Unity, this is where the CSI driver is running, and you can see the CSI driver consists of nodes and controllers. So when I do a -o wide, you will see that it's neatly dispersed between worker 1 and 2. So I have 2 controller nodes running in case one might fail on worker 1 and 2. And each node that is able to schedule workloads or for that matter, be able to run pods, that has a node helper pod to actually make and break the connections. So those are the Unity minus node for worker 1 and 2, so those are these 2 machines. When we look at the default namespace, there's nothing yet defined except for one. So this pod is a snapshot controller, so that's a helper pod for doing the snapshots, which is part of the demo for today. So first thing we should do is definitely create a persistent volume. So we can do that simply by applying a small YAML file called pvc.yaml. It is running, so if I do a kubectl get pvc, you will see that, yep, it's pending, so it's being constructed in the background. So when we look in this file, you'll see that it's very simple. It's just got a standard definition file for Kubernetes, right? It's a standard YAML file. The kind is persistent volume claim. We give it the name pvc minus Unity, and we're making use of the storage class Unity minus iSCSI. If I change this into PowerStore minus iSCSI or a PowerMax minus Fiber Channel, it will go out to that array in that specific way of connectivity. For this demo, like I said, we're using Unity iSCSI, so that's basically for a developer where it ends in complexity, right? You just specify the storage class and the CSI driver will take care of the rest. So we're specifying read-write once and a 5 gig volume. So let's see in the meantime, yep, by now it is bound, so it has been created and it's been surfaced up into the Kubernetes layer. We could actually verify this by looking at the block storage, and we should see a volume here. Yep, we have a volume, CSI volume minus big number. So that's the CSI volume, the 5 gig volume that I just requested. We may already see host access defined as well. No, not yet. So as we will be deploying or connecting actually the persistent storage into a pod and running that pod, you would understand that you would need host access from the storage array into the Kubernetes platform. That will all be managed by the CSI driver itself the moment we actually connect a pod into it. So that's our next step. So kubectl apply -f nginx -pvc, so a simple demo nginx pod. And there we are running. So kubectl get pods. We should see that it's creating the container at the moment. So let's just take a look inside this nginx file. It's just kind pod, right? We're giving that a name. The only special thing about it, not so much the image, right? We're using the standard nginx image, which really doesn't matter because we just need something to run for the purpose of this demo. The interesting part is where we have the volumes, right? We have we're using the claim name pvc -unity. So that is actually the one that we just created. We're using the other YAML file. And next we are connecting that one into an export/nginx mount path, which means whenever the container accesses this specific folder, it won't go to anything within the container, but it will actually go out into the Unity and perform any actions on the persistent storage rather than inside the container. So in the meanwhile, let's see whether this is already done. Oh, you can see that it's running now. So with that, we should be able to actually execute a command remotely. So from the container's perspective by saying a kubectl exec and then specifying the pod name. And then I'm just going to touch a file in there. So that's in the folder /export/nginx. And I'm going to say I was here. So I'm going to touch this file. Next, I should be able to see the content of that folder by doing an ls. And as you can see, the file I was here was created. So now I have this persistent storage. So to prove that the storage is actually persistent, I could simply go out and delete the pod. So I just deleted the pod. Of course, I didn't delete the persistent volume. So if I then go back and I create the pod again, like so, we should actually have a new pod running. So the container was destroyed and rebuilt. But the moment it's up and running again, of course, it's still creating. So let's just wait for a while. And it's running now. So now we should be able to repeat the ls command. And as you can see, the I was here is still there. So even though we destroyed the container and rebuilt it, we still have this persistency in there because this persistent volume was created. So now on to what we were actually here to do, is creating a snapshot. So if we want to create a snapshot, I can simply say, apply this simple YAML file called snapshot.yaml, and it executes. Okay, so when we look inside snapshot.yaml, you'll see that the kind is a volume snapshot. So the name is nginx -snap, and we're actually building that out of pvc Unity, which was our original volume. So up next in the same YAML file, what we also do is that we create a persistent volume claim that we connect to that snapshot. So from nginx snap that we created up here, we're now doing a persistent volume claim all in one go. So when I look at that, kubectl, I could say get me the volume snapshots. And then you see we have the nginx snap. And if I do a get pvc, so that's part 2 of the YAML file, you'll see that I now have a pvc from snap that's also bound and ready to go. So again, if we verify inside the Unity, let's see what we have now. You can see we have 2 CSI volumes. One is the original one, and the second one has a base of this one. Right, so this is actually a PVC created from the snapshot. And if you look here and we edit the original volume, you should be able to see the snapshot sitting here. And there we go. So that was all that we needed to do to actually create a snapshot, mount it, and surface it back into Kubernetes. So now that we have this, obviously as we were running the pods, right, if we do a host access control, you will actually see that the environment is now connected, right? You can see that both the Kubernetes workers were automatically added. So CSI driver takes care of everything down to the storage layer to actually make it work. Okay, so now we have a snapshot. So what I could basically do is go back to my touch, and where is it? Here. And I can touch the original volume with I was here too. So if I do an ls now, I was here and I was here too. If we can look in the snapshot, of course, the I was here too file should be missing. So in order to get that working, we can actually build another pod. So that's called nginx snapped. So this is basically, if we look inside, it is very similar to the one we had before, but we're not connecting the volume into the original PVC, but we are using PVC from Snap, so the one we just created from the snapshot. So we're linking this, connecting the snapshot into this particular pod. And if we do an ls on that one, so ls, but this time the snapped pod, oops. So you can see when I do the kubectl exec, I had to wait a bit for the container to actually be created. But right now you can see that there's just I was here and there, and not the I was here too. So proving that it was actually connected to the snapshot. So with that, all that basically remains is maybe to do a quick demonstration of something very closely related to a snapshot, which is a cloning operation. It's very simple, right? It's very similar to what we had before. I can just do a clone.yaml, and now it will actually launch the clone, right? If I look inside this file, you can see that it's just a persistent volume claim, but we're using the data source PVC minus Unity. So basically we're saying, please create a clone of PVC minus Unity and mount that clone into the environment. So if I do a kubectl get PVC, we should be able to see the clone sitting there, and it's bound as well, so it's ready to go. When I look in here in the block, I should see a third CSI volume, which is also based off of the original one. So as you can see, we now have the original volume, and we have two that have a thin clone base of the original one. So one is the snapshot and the other one is the clone. So with that, I would like to say thank you very much for watching this video. As you can see, it is very simple from a developer's perspective and very powerful to use clones and snapshots within a Kubernetes environment. So this particular demo was around Unity. As you can imagine, if I were to change the storage class into PowerStore or into PowerMax or into any other supported array that we might have, it would just go out and do whatever is required to that storage array, completely automated. So that's it. Thank you for watching, and goodbye.